Hello everyone. This video is about the testing of hypothesis, which is an essential concept in statistics. Let us dive into understanding how we test assumptions and make data-driven decisions. What is a hypothesis? A hypothesis is an assumption or an idea proposed for the sake of argument so that it can be tested. It is an educated guess about a population parameter that we seek to test through data and statistical methods. The idea is to either support or reject the hypothesis based on the evidence from sample data. This hypothesis we are dividing as two types. One is the null hypothesis, which is usually denoted as H0, is the hypothesis that assumes there is no statistical significance between two variables. It suggests that any observed effect or relationship is due to chance or random variation rather than a real underlying relationship. In simple terms, it asserts that no effect or no difference exists. For example, if you're testing a new medication, the null hypothesis could be the new medication has no effect on the patient's health. In hypothesis testing, we begin by assuming that the null hypothesis is true and collect data to test if there is enough evidence to reject it. The second one is an alternative hypothesis, which is denoted as either H1 or H alpha, is the hypothesis that proposes there is a statistically significant relationship between two variables. It suggests that the observed effect or difference is real and not due to random chance. For example, for the same test with the new medication, the alternative hypothesis might state the new medication has an effect on patient's health. In hypothesis testing, if the data provides strong enough evidence, we reject the null hypothesis and accept the alternative hypothesis. What is a hypothesis testing? Hypothesis testing is a statistical method used to determine whether there is enough evidence to reject a null hypothesis. This process is a key part of statistical inference, where we use sample data to make conclusions or generalization about the larger population. Hypothesis testing allows us to evaluate if the evidence gathered is strong enough to refute the null hypothesis and support an alternative hypothesis. It is a fundamental process in statistics because it helps researchers make information decisions based on data, whether that's rejecting a false assumption or providing a significant effect exists. Types of hypothesis test. One-tailed test. A one-tailed test is used when the alternative hypothesis predicts a specific direction of the effect, either greater than or less than a certain value. Essentially, it tests for the possibility of an effect in one direction only. In this type of test, the researcher is interested in testing if the sample provides enough evidence to support a directional change or difference, either greater than or less than a specific value. Let us consider an example. Null hypothesis H0 mu equal to 50 and the alternative hypothesis mu greater than 50. So, we are testing if the data shows enough evidence of an increase in the mean. Otherwise, we can also consider alternative hypothesis mu less than 50. In this case, we would be testing if the data shows evidence of a decrease in the population mean. This is a graphical representation of one-tailed test. And here in this first normal curve, we can see the left-hand side is getting shaded. That means the critical region or the rejection region is falling on the left-hand side of this graph. And for the second graph, we can see the critical region, that is a shaded region, is on the right-hand side. So this is an example of a right tail test, and this is an example for left tail test. In both the cases, the critical region or the rejection region is restricted either on the left-hand side or on the right-hand side of this graph. Therefore, this type of test is called as one-tailed test. Second type of hypothesis test is two-tailed test. A two-tailed test is used when the alternative hypothesis suggests that the effect could be in either direction, greater than or less than a specific value. This type of test check the deviation in both direction from the hypothesized parameter. In a two-tailed test, the critical region is in both tails of the distribution, which means that we are testing for both an increase and a decrease from the hypothesized value. Let us consider an example. Null hypothesis H0 mu equal to 50 and an alternative hypothesis mu not equal to 50. Here the alternative hypothesis suggests that the population mean could be either greater than or less than 50, and we are testing to see if the data provides enough evidence for either possibility. This is a graphical representation of two-tailed test. Here we can see the critical region or the shaded region will be there on left hand side as well as on the right hand side. So the critical region will be falling on both the tail of this graph. We can say this is a two-tailed test. Steps in hypothesis testing. The first step in hypothesis testing is to clearly state the null hypothesis and the alternative hypothesis. Null hypothesis assumes that there is no effect or no difference in the population. It represents the idea that the observed effect is due to chance. Alternative hypothesis suggests that there is an effect or a difference in the population. It represents an idea we are trying to test and support. The next step is to select the significance level alpha, which represent the probability threshold at which we reject the null hypothesis. The significance level is commonly set as 0.05, meaning there is a 5% chance of rejecting the null hypothesis when it is actually true. The third step is to select the appropriate statistical test based on the type of data you have. The choice of test depends on factors like the data scale, the sample size, and the research question. Common tests include t-test, which is used for comparing means between two groups. Z-test, used when the sample size is large or the population variance is known. ANOVA, or analysis of variance, used to compare means across three or more groups. For example, if you're comparing the mean test scores of two groups, you might use a t-test. If comparing three or more groups, an ANOVA might be appropriate. The fourth step is to calculate the test statistic based on the sample data. This statistics helps to quantify the difference between the sample data and the hypothesized population parameter. Common test statistics include t-value, which is used when the population variance is unknown and the sample size is small. Z-value, used for large sample or when population variance is unknown. F-value, used in ANOVA when comparing more than two groups. For example, If we are conducting a t-test, we calculate p-value to determine how much the sample mean deviates from the population mean relative to the sample standard error. The next step is to find the p-value. The p-value is the probability of obtaining the observed test statistic or something more extreme, assuming that the null hypothesis is true. It helps us assess the strength of the evidence against the null hypothesis. A small p-value, typically less than or equal to 0.05, indicates strong evidence against the null hypothesis, suggesting we should reject the null hypothesis. A larger p-value suggests weaker evidence, means we fail to reject the null hypothesis. Once we have p-value, we make a decision. If the p-value is less than alpha, usually 0.05, we reject the null hypothesis and conclude that there is sufficient evidence to support the alternative hypothesis. If the p-value is greater than alpha, we fail to reject the null hypothesis, meaning there isn't enough evidence to support the alternative hypothesis. In other words, the p-value helps us determine whether the evidence is strong enough to contradict the null hypothesis. The final step is to state the conclusion. Based on the decision from step 6, draw a conclusion about the hypothesis. This conclusion should clearly answer whether or not the null hypothesis is rejected and whether alternative hypothesis is supported. For example, if the null hypothesis is rejected, we conclude that the sample data provides sufficient evidence to support the alternative hypothesis. If the null hypothesis is not rejected, we conclude that the data does not provide enough evidence to support the alternative hypothesis. In summary, these steps connect the result of the hypothesis test to the research question, giving the final answer to the study. Thank you.